Right, so let us start chapter 11 today. This is the first class after Idul Adha, and we're starting with chapter 11. So the name of the chapter is Interrupts Programming in Assembly. Anyone who has any idea of what is the meaning of interrupts? Anyone with any idea? Okay, so what is the difference between interrupts and polling? Any idea?
No, sir. No, sir.
So let me start. By this time, I think all of us already know that one microcontroller can be connected with several devices. You can connect several devices with one microcontroller, or more specifically, we can say that we can connect one microcontroller with different chips or ICs. Okay, it can be connected. So that means your microcontroller needs to control all those devices which are connected to it. Now there are two methods by which your microcontroller can do that. One of the method is interrupts and another method is polling. So what is the meaning of interrupts? The meaning of interrupt is that, try to concentrate, okay, because I'm not writing, I'm just verbally explaining, I'll not be writing this thing. So the meaning of interrupt is that whenever any device connected to the microcontroller needs the service of microcontroller or needs something to be done by the microcontroller, the device will send an interrupt signal to the microcontroller. I repeat, if any device needs the service of the microcontroller, the device notifies the microcontroller by sending an interrupt signal. The signal might be anything, okay? The interrupt signal can be anything. The requirement of service also varies from device to device. But the main thing is that whenever it is needed, whenever a service is needed by the device, it will send a signal to the microcontroller. On the other hand, what is polling? Polling means your microcontroller will continuously monitor the status of a device. Say 5 devices are connected, okay? So microcontroller will start monitoring device number 1 and it will allocate some time for monitoring device 1. Then it will start monitoring device 2. Then it will start monitoring device 3. In this way, this is known as round robin fashion. I believe all of you already know what is round robin fashion. So in round robin fashion, your microcontroller keeps on monitoring each of the devices individually, irrespective of the necessity whether the device needs its service or not. That is known as polling. Have you understood the difference?
Sir, is
Yes,
polling
no?
something that a microcontroller always does on its own, or some specific function has to be given to it?
Okay, it's not. It is not that function is being given or not. Whether you are activating the interrupt or not, it depends on that. Whether if you want your microcontroller to act on interrupt, then that is known as interrupts. If you want your microcontroller to keep polling, it will keep polling. It is up to the user. I mean, your microcontroller can do both the things. If you want your microcontroller to respond to an interrupt, it will do that. On the other hand, if you tell your microcontroller to keep on, you guys already came across polling. I will give you an example. You guys already know what is polling. I mean, you just don't know the term, but you guys already know which is polling. What my question over here is, which one do you think is more efficient, interrupt or polling? Which one is more efficient?
So interrupt.
Okay, why do you think interrupt is more efficient?
So it sends the signal when it's necessary. So it doesn't send any unnecessary monitoring signals all the time.
Okay, any other point? Let's see, the advantage of interrupt is that, see, we say that the microcontroller will poll means it will check the status of a device continuously for a specific period of time, then it will go to the next device. In this way it will keep on going. So you see that, say you have given some task to device 1 and you have set the device that whenever you finish the task, the microcontroller will need to do something. So in polling, the microcontroller will keep on checking the status of device 1, whether it has finished or not. On the other hand, if you activate interrupt, then whenever device 1 finishes its work, it will tell the microcontroller that I have finished my work. In the meantime, you can engage your microcontroller in doing some other works. Have you got the point? If your microcontroller is in polling mode, it cannot do any other thing. But if you activate the interrupt mode, then you can engage your microcontroller on any other work. So whenever that interrupt will be invoked, your microcontroller will save the status of whatever it was doing. Then it will come to this interrupt. It will perform whatever it has to do. And then again, it will again get back to the work it was doing. Have you understood the difference between polling and interrupt?
Yes, sir.
There is another thing that can be done while interrupt is that you can assign priorities. Like say you have connected 5 devices, okay? You can assign priorities, that which device is your top priority, then which one is the next priority, so that even if at the same time multiple devices invoke the interrupt, your microcontroller can respond according to the priority set. Now let me give you an example. In chapter 9, that is the chapter we have just finished, right? Chapter 9. There was an instruction like this. AG. Do you remember there was an instruction like this?
Yes, sir.
What did it actually do over here? I mean, why did you need this? What is TF? Anyone? What is TF?
Timer overflow flag.
Uh-huh.
So the timer overflow flag.
Timer overflow flag, right? Why do we need TF?
Sir, we keep on checking if there's an overflow, sir.
We keep on checking whether there is an overflow. That means we try to monitor to see whether the timer or counter has finished its counting or timing, right?
Yes, sir.
So this is an example of what? Polling or interrupt? This is an example of what?
Sir, polling.
Sir, interrupt, sir.
Okay, someone said interrupt, someone said polling. Okay, let's share the logic. So whoever said polling, why do you think it is polling?
Sir, it is continuously checking the value of the overflow flag, sir. So until a specific time, the overflow flag becomes 1, it reaches back to its restart value. So I guess it will be polling, sir, because of this cause.
Okay, whoever said interrupt, why did you think it is interrupt?
Sir, when it is, sir, maybe we need to send a signal and we stop there. So maybe it's interrupt. Maybe I don't have any clear idea.
Sir, I think the timer sends the signal to the microcontroller. Then microcontroller jumps to the interrupt routine. That's why it's interrupt.
All right. So this line says jump not bit TF again. That means as long as TF is not bit, it will keep on jumping over here. If it becomes TF, then you provide the corresponding instructions over here. So is there any interrupt service routine over here? Is there any interrupt service routine over here?
I didn't understand. Can you repeat again?
Okay, someone said that whenever it finished the work, it sent a signal to the microcontroller, and from that signal, from interrupt service routine, I think this was also the term that you used. From interrupt service routine, your microcontroller can do other things, isn't it? Isn't this what someone said?
Yes, sir.
Okay, I mean, how did you understand that? I mean, from where a signal is being sent to the microcontroller? In this line, how are you sending a signal to the microcontroller?
So by the timer, like, sir.
By this timer flag, are you sending any signal? I mean, this timer flag will either be 0 or 1. Is it sending any signal?
Sir, when it's reached the certain value, then it's get 1, sir. So is it a calling is signal or not, sir? I'm not clear.
Okay, it is actually polling. See how you are understanding it. Whether we are having 0 or 1, I mean, it is being controlled by this one, JNB, right? JNB decides whether you will jump in this loop once again or not. If you jump, then you will come over here. If you do not jump, you will come into this line. That means your microcontroller is continuously checking the status of this TF flag. Until and unless this TF flag becomes high, your microcontroller stays in this loop and it keeps on checking. Isn't that polling? I mean, continuously checking the status of something. Isn't that polling?
Yes, sir.
Whenever we'll talk about interrupt, you will see that there are certain ISR. Someone just said that it is correct. Interrupt service routine. You will see that ISR will be invoked, which we will learn next. So you'll see that thing. Anyway, so if you are asked in the exam, write down the difference between interrupt and polling. Can you do that with proper examples? Come on, yes, no, something.
Can you show an example about interrupt, sir?
I cannot show you an example of interrupt because we have not yet started anything regarding interrupt. I have not yet taught how to activate an interrupt or how to send an interrupt, right? So I need to teach you that first.
Sir,
But in plain language, you can define, right? Yes.
sir, with interrupt, you said that we can also the microcontroller can do other functions as well. So when the interrupt is going on, if I give it another function, it will conduct both of them simultaneously.
No. Good
Then?
question. No. Say your microcontroller is performing some task, okay? And then an interrupt has been invoked. So what your microcontroller will do, it will, whatever your microcontroller was doing, it will finish that particular line of task. Then the next instruction, your microcontroller will save the address in the stack, and it will save everything that has been done by the microcontroller. Then according to the interrupt, your microcontroller will serve that particular device. After finishing serving that device, your microcontroller will get back to whatever it was doing. Have you understood now?
Yes, sir. But in case of polling, I'm also doing, suppose I have 5 devices connected with the microcontroller, and the microcontroller has finished performing the polling function for all the 5 devices. Then next, won't it just go back to the work it was given? Or it will again restart from?
Yeah, it will again restart from device 1. I mean, that is the work of the microcontroller. 5 devices are connected, right? So it will keep on checking all the devices in a round robin fashion.
No, I'm saying that suppose the microcontroller was doing a task, then like interrupt, I have invoked the polling function. So for here, it will once the timer overflow flag, suppose I have given that if the value becomes 1, then it will go to clear. Next, so it has checked for all the functions, and then it has seen that it has seen that for the last function that it's it has conducted for all the devices. Next, it will jump to clear, right? Suppose the work for all the devices, polling for all the devices has been completed. Then what will happen? It will again restart from that place, but it can't go back to the work it was assigned before polling. Is that what you are saying?
Okay, what? Let me try to say again. Then you let me know whether I got your question or not. The work of a microcontroller is controlling the devices that are connected to the microcontroller. Okay. Assume 3 timers are connected to the microcontroller. Let's keep it simple. 3 timers are connected. Okay. So when you are running timer 1, and this is the instruction of timer 1, like jump not bit TF1 then AG. So as long as this instruction is not being finished, your microcontroller will keep on monitoring this timer 1. Then when everything of this timer 1 has been finished, your microcontroller will go to timer 2. then it will keep on monitoring timer 2, whatever timer 2 is doing or whatever services it needs. It will keep on monitoring timer 2. After finishing that, it will go to timer 3. After finishing timer 3, it will again come back to timer 1. Then again it will go to timer 2. In this way, your microcontroller will assign certain amount of time during which your microcontroller will monitor each of the devices, and that itself is the work of microcontroller. I mean, only 3 devices are connected to the microcontroller, right? So your microcontroller will control those 3 devices. But if you activate polling, that means, say you are monitoring timer 2. In that case, timer 1 needs your service. Your microcontroller will not do that because it is monitoring timer 2. After monitoring timer 2, it is supposed to go to timer 3. So it will go to timer 3. It will not come back to timer 1. Then finishing timer 3, it will come back to timer 1. Have you got now?
Yes, sir, I understood now.
All right. Any other question, anyone? All right. So now let us get into interrupt. Okay, how we can execute an interrupt. So these are the steps that your microcontroller goes through whenever an interrupt is invoked. So what is the first thing it does? It finishes the instruction it is executing, and it saves the address of the next instruction on the stack. Remember, it says it finishes the instruction it is executing, not the entire task. Whatever instruction, specific instruction your microcontroller was executing, your MUSI will finish executing that particular instruction only. Then the next instruction will be saved onto the stack. Then it will also save the current status of all the interrupts. I mean, if there are multiple interrupts, then the current status of all the interrupts will be saved internally. This save will not be in the stack. Okay, this will be saved by the microcontroller internally, but this one will be saved onto the stack. That means for the next instruction, definitely there will be a program counter, right? We already know what is PC. So there will be a PC which will correspond to the next instruction. So the address of that PC will be stored by the microcontroller onto the stack. Then it will save the status of all the interrupts. Then it will jump to a location held by the interrupt service, sorry, interrupt vector table. I'll show what is this table. This table is nothing. This table simply holds the address of the interrupts. I mean, definitely in the memory location, there has to be some address where you store the instructions that will take place if an specific interrupt is being invoked. So whenever an interrupt will be invoked, based on that particular interrupt, your microcontroller will jump to a location held by the interrupt vector table. When I will write the interrupt vector table, I believe it will be much more clearer. Then it will execute the subroutine until return I is encountered. Okay, so return I is almost similar to pop instruction, because your microcontroller saved the next instruction onto the stack. So to get the address out of the stack, definitely you need a pop instruction. So return I is equivalent to a pop instruction. So you will pop out the address of the program counter and you will get back to whatever your microcontroller was doing. So is it understood up to this? Have you understood or not?
Yes, sir.
Yeah, let me draw the vector table. This is 2.1. It is not necessary to write the table. I think this table is also there in your book. If you want, you can write, up to you. So that's it. We have basically 6 interrupts. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. Wait. 0, 0, 0, then 3, 13, 1. Wait, I made a mistake over here. After B, we have 13. Yes. So we have got a total of 6 interrupts in 8051. 1, 2, 3, 4, 5, and 6. So first one is your reset interrupt, and you can see the address is 0000 and your pin number is 9. So what is the meaning of this? Can anyone explain me? What is the meaning of this? So whenever, let me help you. So whenever reset is invoked, reset interrupt is invoked with the help of pin number 9, what will your microcontroller do? Tell me. If reset interrupt is invoked by the microcontroller, then what will happen?
Sir, usually when reset is invoked, all the pins of the microcontroller have high values.
Right, that is what we discussed in chapter 4, right?
Yes.
But you need to tell the microcontroller to do that. How will the microcontroller know that whenever reset is invoked, it needs to do whatever you just said? How will the microcontroller know? That is what I'm asking. Come on, it is very simple.
Sir, set all the pins high.
See, what is written over here in point number 3? What is written?
It jumps to the location held by the interrupt vector table.
Right. So whenever your reset interrupt is invoked, where will your microcontroller go?
Sir, to ROM location.
It will jump to this location. It will jump to this location, that is 0000. Definitely in this ROM location, you have got certain instructions that is executed by the microcontroller. So what are those instructions? Those instructions are whatever you just said, that make all the pins high or low. I mean, all these things, right? So all these things are written from this address onwards. Have you understood now?
Yes, sir.
I don't think so. You are getting the clear idea. Okay, what will happen if TF0 is interrupted? If TF0 interrupt is invoked, what will happen? It will jump to this location, isn't it? 000B. Then whatever instruction is stored in this address onward, 000B onward, those instructions will be executed by the microcontroller, right? Then again, it will get back to whatever it was doing. Are you getting this idea at least?
Yes, sir.
Yes, sir.
I hope so. If you have understood this much, at least those who are responding, then tell me how many memory, okay? How many memory is reserved for TF0? How many memory location is reserved for TF0? Let's see whether you understood or not. For TF0, how many memory location is reserved?
Sir, 4 bits, sir.
4 bit. Anyone else? for
12
TF0
bit.
interrupt.
12 bit.
Kota?
12.
Okay, so far the answers we got are 4-bit, then we got 12-bit. Any other opinion?
So memory location only.
Yeah, I'm asking how many memory locations are reserved for TF0 interrupt?
So 8 memory locations.
8 memory locations. Okay, and what is the size of each memory location?
So 4-bit.
Size of each memory location is 4-bit.
Yes, sir.
Come on, what is the size of each memory location? Anyone else? What is the size of each memory location?
So 16.
There is no one who can tell me, huh? How much?
16, sir.
No, I'm asking what is the size of each memory location? Did you say 16?
Yes, sir.
Still, if you don't
One
know at
byte.
this stage that exactly 1 byte or 8-bit, come on, it is very obvious. The size of each memory location is 1 byte. So another answer we got is 8 byte. So the question still stands. How many memory location or how many bytes of memory is reserved for TF0? Any other answer, anyone?
Sir, 3-bit.
3-bit. Okay, we have got a lot of answers. Now let us go one by one. Whoever said 4-bit, why did you think 4-bit? Let's see. Come on, just say
The
whatever.
first, sir, the lower first bits are, I assume. The 0, 1, 2, 3, 4.
Okay, so
Sir,
you
sir,
got
0, 1, 2,
confused
3.
with chapter 9. Yeah, you got confused with chapter 9. That was a different thing. You need to answer from this particular table. Okay, so let's cross out 4-bit. Whoever said 12-bit, why did you think 12-bit?
Sir, I just assumed like 0 difference between 0 and 13.
Difference between 0 and 13.
Sir,
This is
13
not
and
0, by the way. This is B.
B.
Also.
Yeah,
Yes.
13 and B. Okay, so this one is also gone. So whoever said 8 byte, what is your logic? Come on, what is your logic? Tell me.
Sir, from B to 13.
Yes, sir. From B
From-
to 13, I got 8. Then I confused with 8 byte.
Right. This is the right answer. Okay, 3-bit is also wrong. Definitely, we have got 8 bytes of memory location, which is allocated for TF0. It is very simple to understand. You are starting from 00B, right? So we have got B, then what? After B comes what?
3.
How much? C, then
Then sir, D,
D, then
E,
E.
then
Keep
1
on going.
1 0.
After E10,
So F, then 1, 0.
F, yeah, then
F,
10,
then
then
1 0. Yes, sir. F, then 1 1, then 1 2.
then 1 then 1 2. So how many we got? 1 2 3 4 5 6 7 and 8. And the size of each memory location is 1 byte. We know this, right?
Yes, sir.
So we have got a total of 8 byte memory location, which is reserved for TF0. So similarly for reset, how many bytes are allocated?
Sir,
How many
two,
bytes are allocated for
1,
reset?
3, 3, sir.
Exactly. So for reset, we have got 3 bytes which are allocated for reset. Have you understood up to this?
Yes, sir.
Yes, sir.
All right. Okay, I think I'll stop over here because I'm getting very low response from you today. Okay, and if you do not respond, it will become difficult for me or for you also to understand. So let me stop over here. Just 2 things. Okay, we have not learned anything at all today. We just saw what are the steps. Okay, no, we started with the difference between interrupt and polling. At least I hope you understood this much. Then we went what are the steps in executing an interrupt. Then we just understood what is the meaning of an interrupt vector table. So have you understood at least these 3 things today?
Yes, sir.
I hope
Yes,
you have
sir.
understood.
I understood.
At least if some of you understands, it's better. I mean, that is all I can expect. Let me stop sharing. Let me just take your attendance. After that, I will let you leave. Yeah, I can see on